All right, Sokotoa. You could stand around and do a little dance that says Sokotoa, 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 but that wouldn't really be all that great, and you'd be sitting there going, what is this crazy guy doing? Trig ratios. How we try and remember our trig ratios is so, ka, toa. You might hear that. That's an A, by the way. You might hear that come around. Basically, you'll find out what it means here in a minute. Sokotoa. It's a way to help remember these trig ratios. Trigonomic ratios relate the side lengths of right triangles to their acute angles. It is a relationship. It is a ratio. A ratio is a fraction. So we make fractions based on side lengths and angle measures. Right? The three basic trig ratios are sine, cosine, and tangent. And we don't write out the word tangent. We abbreviate it TAN. So let's just dive right into it. The sine of an acute angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So opposite over hypotenuse, hence the sine opposite over hypotenuse. The cosine of an acute angle is the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. And the tangent of an acute angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent. Right? Hence Sokotoa. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Okay? Whenever you see O or A, it's referring to a leg. Obviously H is hypotenuse. The basic trig ratios are defined below with respect to angle A. So think of angle A as a starting point. BC is opposite. So if we want to create the sine of angle A, we're going to go BC, because BC doesn't have a number. Usually there would be a number there. BC, which is the leg opposite, over the hypotenuse, which is AB. There's your sine ratio. The cosine is the leg adjacent, or AC, over the hypotenuse, which we already know is AB. And then the tangent is leg opposite, which from before we already know is BC over leg adjacent, which is AC. That's just how you create those ratios. Right? So now let's do it with respect to some numbers. We have some numbers in here. First thing you want to do is, and it says hint, start by labeling the sides. So I'm going to label the sides with respect to R. I always start with the hypotenuse because that's pretty easy. It never changes. Oh gee, here's the hypotenuse. So HYP, there's the hypotenuse. Now, what's the leg opposite? What's the leg adjacent? That's going to depend on where you start from. Here they're saying start from R. With respect to R, 4 is opposite, so now I'm going to label that opposite, and 3 has to be adjacent. Now I can create my ratios. The sine of R is equivalent to, well gee, what's the ratio? So, opposite over hypotenuse. The opposite is 4 over 5. I'm done. There's my ratio. I created that ratio. The cosine of R is equivalent to adjacent over hypotenuse. Well, the leg adjacent is 3. Its value is 3. The hypotenuse, 5, didn't change. And then tangent of R. Tangent of R is the leg opposite over the leg adjacent. 4 over 3. Done. Those are your trig ratios with respect to R. Now these would change. Okay? So now when we look at some trig ratios for our special triangles, and we want to label these with our algebraic, well, now we don't have to, but if we did, we labeled these with our values. That doesn't matter in this case right now because we actually have valued numbers. So what it wants me to do is it wants me to get the sine of 45 degrees. Well, in this case, it doesn't matter where I start. I'm going to start down here. The leg opposite is 1. The hypotenuse is always the hypotenuse. So 1 over the square root of 2. Now, what we should do is, because this is not a valid answer, because it has a decimal, it's irrational in the bottom, we should make sure we multiply both sides, or both top and bottom, by the square root of 2, so we get the square root of 2 over 2. That would be the correct answer. So the square root of 2 over 2. Okay? If you got 1 over rad 2 for now, that's okay. cosine of 45 degrees. Well, cosine is leg adjacent over hypotenuse. Leg adjacent is 1. Hypotenuse is still rad 2. So 1 over the square root of 2, or radical 2 over 2. Why did I not show any work? Hey, I already did my work up here. All right? Work smarter, not harder. The tangent of 45. Tangent is leg opposite over leg adjacent. So the tangent for this is going to be 1 over 1. Done. All right? Now, what about in my other triangle? Well, again, maybe it's good to label all of your stuff. HYP, HYP. In this particular case, well, it depends on where I start. The sine of 30, if 30 is here, then 1 is the opposite leg. Okay? So I'm not going to label it opposite. I'm just going to label it leg for right now, because I got to do the sine of 60, and that opposite and adjacent thing could change. So the sine of 30 is going to be opposite over hypotenuse. So 1 over, I'm holding on both sides there, 1 over 2. Can't hold on to both sides and mark twice there. Doesn't work. The board doesn't like that. How about the cosine of 30? Well, cosine of 30 is the leg adjacent, which is rad 3 over hypotenuse. So radical 3 over 2. This is an acceptable answer because the radical's in the numerator. Now, how about the tangent of 30? The tangent of 30 is going to be the leg opposite over the leg adjacent. 1 over radical 3. See how I picked those, opposite and adjacent, out of the sine cosine ratio? I didn't have to look back up there. And this we would simplify. Multiply both sides, or top and bottom, by the square root of 3. So we get rad 3 over 3. Excuse me. Sine is 60. Now, here's where it changes. Okay? The sine is 60, different starting point. Rad 3 is now the opposite. So, rad 3 over 2. Cosine is 60. 1 was adjacent, so 1 over 2. And then down here for the tangent, you get the tangent of 60, you get the square root of 3 over 1. Now, what do you notice about here? What I notice is the sine of 30, cosine of 60 are the same. Cosine of 30, sine of 60 are the same, and these are inverses of each other. Why? Because you may have noticed that the sine of 30 and cosine of 60 are both 1/2. In general, if the angle A and B are complementary, then the sine of A is the cosine of B, and the cosine of A is the sine of B. So they're in a sense inverses of one another. Now, for your homework, what we did here, we went ahead and we labeled the triangle first, opposite, adjacent, hypotenuse, with respect to the indicated angle. A is the indicated angle, so opposite is 7, hypotenuse is 8.06, and 4 is adjacent. So now you can create your ratios. And that's all it's asking you to do. The cosine is adjacent over hypotenuse, so 4 over 8.06. Sine is opposite over hypotenuse, so 7 over 8.06. And tangent is opposite over adjacent, 7 over 4. Now the only other thing it says is if you have a missing side, which you will, find it, but work smarter. Notice both of these triangles are the same. So if I find CA for this side, I know CA for this one. If I find CA for this one, I know CA for that one. Don't do double the work, right? But you need to show me work for one of these. Show me work for one of these as to how you find that angle, all right? So ask questions. Quiz tomorrow on 30, 60, 90s. If you're watching this, ask questions, please.